Good morning to everyone. I'm Rupa from ECA section. My roll number is 24BQ180401. I'm now telling a seminar about HTLD. In this, I am discussed about buffer resistors, control resistor, shift right resistors, left resistors, and universal shift resistors. And a shift resistor is a group of flip-flops connected in series to store and shift multiple bits of data either left or right with clockwise. The register that shifts the data left side is called shift left register. The register that will shift the bits to the right is called shift right register. And the next is based on the data load and retrieval from the registers. The registers are classified into four types. First one is CISO, means serial in, serial out. Second one is serial in, SIPO, serial in, parallel out. Third one is parallel in, serial out. And fourth one is parallel in, parallel out. And the next slide is about buffer resistor. Now we are explaining about buffer resistor. Buffer resistor is a buffer resistor in a digital electronics is a storage until that holds binary data, built using a series of D flip-flops with each flip-flop storing 1 bit. Data is loaded into a buffer resistor at each clock tick, with outputs matching input bits at each loading clock edge. Its primary function is to act as a temporary storage area for data being transferred between devices or computers, helping to match the different speeds of faster slowing devices. Control buffer resistor. Buffer resistor that control over inputs causing uncontrolled outputs. To fix this, control buffer resistors are used. And why is buffer resistor is used? Some devices like CPU, memory, input devices works at different speeds. The buffer resistor stores data temporarily so that fast devices do not have to wait for slow devices. It ensures smooth and efficient data transfer. Functions of a buffer resistor. Temporary data storage during data transfer synchronizes different speeds of devices, reduces delays in data processing, prevents data losses by holding data until the next device is ready. Examples of buffer resistors. Input buffer resistors means IBR holds instructions fetched from memory before execution. Output buffer resistor holds data before it's sent to an output device like a printer. Memory buffer resistors, MBR, or it is also called as memory data register, holds data being transferred to or from main memory. Now we are discussing about why do we use buffer resistors. Inside the CPU during instruction execution, input devices in communication systems in memory systems. And input devices we use it as keyboard, mouse, printer. In communication systems, in memory systems, we use it as RAM and cache transfer. Simple example we now see. Suppose the CPU can process data very fast, but a printer prints one character at a time. Data from CPU stored in output buffer register. Printer takes from the buffer prints slowly. CPU continues its work without waiting. Thus, this avoids delays and increases system efficiency. And the next is about, in this slide, we see the buffer register. In previous slide, we discussed about that. After that, we have control buffer resistors. Buffer resistors rack control over inputs, causing uncontrolled outputs. To fix this, control buffer resistors are used. In this design, tri-state switches are used to control the operation of loading and or retrieval of the data to or from the buffer resistor. Here, one has to pull the control line, means blue line, low in order to store the data into the register, while control line red line should be made low to read the data. A control buffer resistor is a special type of resistor that transfers data only within when its control signal is active. It is used in digital systems where data movement must be precise, timed, and controlled. Definition: a control buffer register is a register that stores data temporarily and allows the data to pass to the next stage only when an enable or control signal like enable load rate is given. It holds data plus releases it only when control logic allows. Why is it called controlled? Because its operation depends on control signals load, enable, write, read, flow. Working of control buffer register. Data is placed at the input. A control signal is activated only then the register stores the data or sends data to the next block. If the control signal is off, data is blocked. Unwanted data transfer, data corruption, synchronizes issue. These are all prevented by the control levels. Features. These have some features. Temporary storage, control data flow, synchronization between CPU, memory, and input devices, prevents overflow or unwanted data propagation, where CBR is used. Memory data register, input or output controllers, direct memory access, pipeline stages in CPU. Now we see simple example. If data is put into the control buffer register when memory equals to 1, the control line enables output. Data moves to memory. When memory ready equal to 0, data held inside the register. This prevents CPU from sending data when memory is not ready. And next we talk about we see the diagram. This is about the control buffer register. And the next one is shift register. The register that transfers or shifts input data right ports is called the shift right register. When the rising or falling clock edge arrives, then the stored bits shift rightward according to the 1-bit position per clock pulse. Data is entered into the register from the left side and data. Next one is shift left register. The register that transfers or shifts input data leftwards is called the shift left register. When the rising or falling edge arrives, then the stored bits shift leftward according to the 1-bit position per clock pulse. Else data is entered into the register from the right side and data is retrieved from the left side. And next, a universal shift data is an n-bit register that supports both left and right shifting as well as parallel loading using the n flip-flops and n multipliers with shared select lines to control the data flow. It combines the features of bidirectional and unidirectional shift registers, enabling versatile data manipulation, shift left, shift right, parallel load, and hold S0, S1, 00110 operation, hold left, right, shift 1, parallel load call. It has also some types. One is hold for 00, shift right for 10, shift left for 01, parallel lines for 11. Basic modes of operation. So hold mode, shift left, shift right, parallel. And control inputs. If S1 equal to 0, S not equals to 0, the operation will be hold. If S1 equal to 0, S not equals to 1, that is shift right. If S1 equal to 0, it has some applications. Shifts are widely used in shifts are widely universal shifts are widely used in serial communication, converting data between serial and parallel arithmetic operations, multiplication or division by shifting bits, data storage, counters and sequence generators, digital signal processing, microprocessor, and S1 equals to 0, S not equal to 0, the operation will be hold. S1 equals to 0, S not equals to 1, operation will be shift right. S1 equals to 1, S not equal to 0, operation will be shift left. S1 equals to 1, S not equals to 1, operation will be. Your universal shift usually contain two control bits, S1 and S0, to select the operation. In this, both are occurring in that. After that, universal it has communication. We already saw an application. Universal are widely used in the present days. Also, universal have so many applications. And now arithmetic operations are also done in that serial communication, arithmetic data storage, counters. Counters means already we seen that register sequence. In register, this is also universal. In universal register, both bidirection, unidirections are occurred. Universal shifter is a device that can store data and shift the data in multiple directions. It is called universal because it can perform all type of shift